Hey everyone, welcome to Neural Notes, show where AI comes alive. Smash that subscribe button and ride the innovation wave.
Hello students, today's lecture is the fourth video in the series of History of Psychology. And today, we are going to dig into a really radical idea, the idea that you are not born, but made. What if I told you that everything you are, your fears, your personality, your talents, wasn't hardwired from birth, but was actually built, piece by piece, by the world around you?
And, this isn't just some random thought experiment. This is a real quote from John B. Watson, who's really seen as the founder of this whole movement. His big goal? He wanted to completely rebuild psychology from the ground up. He wanted to get rid of all the fuzzy, unseeable stuff about the mind and create a pure science based only on observable behavior. This one quote really captures his entire philosophy, that we are all blank slates, and our environment shapes almost everything we become.
So this new movement got a name, Behaviorism. And to build their new science of behavior, they first had to tear down the old way of thinking, and that meant rejecting the very idea of even studying the mind.
And this right here was the fundamental divide. For decades, psychology had relied on something called introspection, basically looking inward at your own private thoughts and feelings. But Watson and the behaviorists came along and said, whoa, hold on a minute. How can you build a real science on something nobody else can see or measure? Their solution was pretty extreme. If you can't observe it, it's not science, period. Psychology, they argued, must only study what we can all see and measure: behavior.
Okay, so you might be thinking, what about those earlier, more objective methods? Remember researchers like Donders who were measuring reaction times to figure out how long a decision takes? That seems pretty scientific, right? It's got numbers and measurements. So would a behaviorist be okay with that?
Well, they were kind of halfway there. Behaviorists absolutely loved the first two parts: controlling the input, the stimulus, perfect; measuring the output, the behavior, excellent. But that last step, making a guess about some mysterious internal decision, nope, that's where they drew a hard line. To a strict behaviorist, the mind was a black box. You can measure what goes in, and you can measure what comes out, but you can never, ever claim to know what's happening on the inside.
So, if your whole theory is that the environment is everything, how in the world do you prove it? Well, Watson decided to take on one of our most powerful emotions, fear, to show that it wasn't something we're born with, but something we learn. And to do this, he designed one of psychology's most famous and, frankly, most controversial experiments.
Here's the setup. Watson took an infant, known to us as Little Albert, and showed him a white rat. Albert, like most babies, wasn't afraid at all. Then Watson did the scary part. He snuck up behind Albert and slammed a steel bar with a hammer, making a horrible, loud noise. Naturally, Albert started crying. Now, after doing this over and over, showing the rat, then making the noise, something profound changed. Soon, just seeing the white rat was enough to make little Albert burst into tears.
And get this, the fear didn't stop with the rat. It generalized. Albert became afraid of a rabbit, a dog, even a fur coat. For Watson, this was the smoking gun. It seemed to prove that a powerful, raw emotion like fear wasn't an instinct, but was learned through simple association. This experiment became the cornerstone of his argument that we are all products of our conditioning.
Now, Watson's ideas about learning by association didn't just appear out of nowhere. He was really standing on the shoulders of a giant, a Russian physiologist named Ivan Pavlov. And Pavlov had accidentally discovered one of the most fundamental types of learning while he was just trying to study how dogs digest their food.
This process is called classical conditioning. It might sound a little technical, but the core idea is actually incredibly simple. It's just that our brains are wired to connect events that happen together in time.
The classic example, of course, is Pavlov's dogs. We all know dogs naturally drool when they see food. You don't have to teach them that. It's an unconditioned or unlearned response. Now, a sound, like a clicking metronome, means nothing to a dog at first. It's neutral. But if you start clicking that metronome right before you give the dog its food over and over again, the dog's brain starts to make a connection. And pretty soon, all you have to do is click the metronome, and the dog will start drooling, even if there's no food anywhere in sight. A new connection has been formed. Learning has occurred.
Okay, but what about behaviors that aren't just automatic reflexes like drooling or being startled? What about all the voluntary choices we make every day? The next giant of behaviorism, a guy named B.F. Skinner, decided to tackle this. He shifted the focus from learning by association to a new idea, learning by consequence. Now,
To study this properly, Skinner knew he needed absolute, total control. So he invented one of the most iconic tools in all of psychology, the operant chamber, which everyone now just calls the Skinner box. It was this perfect little self-contained world where he could control every single input and precisely measure every single behavior that resulted. And inside this box, Skinner studied what he called operant conditioning. And again, the idea is beautifully simple. Actions that are followed by good consequences tend to be repeated. Actions followed by bad consequences, not so much. It's all about how our behavior is shaped by what happens after we do something.
So let's picture it. You've got a hungry pigeon in a Skinner box. It's just kind of moving around randomly. But then, just by chance, it happens to turn its head a little to the left. And at that exact instant, bam, a food pellet is delivered. The pigeon just got a consequence for that specific action. So what do you think happens next? The pigeon starts turning its head to the left a whole lot more often. Skinner showed that through this process of shaping, you could teach an animal to do incredibly complex things, all by rewarding these little step-by-step approximations.
So let's pause for a second, because this is the key difference you have to get. In classical conditioning, the process pairs two stimuli together, like the metronome and the food. The learner is totally passive. The drooling just happens to it. But in operant conditioning, we're pairing a behavior with a consequence. Here, the learner is active. Its actions operate on the environment to produce some kind of outcome. That's a huge difference.
You know, this obsession with being purely objective, purely scientific, it went all the way down to the very words they used. To be a true science, behaviorists knew they had to invent a new vocabulary, one that was completely scrubbed clean of any messy, subjective ideas like feelings or intentions. I mean, why not just say reward and punishment, right? It seems simple enough. Well, because a word like reward implies a subjective feeling like pleasure or happiness, and for a strict behaviorist, that is totally off limits. You can't scientifically observe if a pigeon feels happy when it gets a food pellet. All you can observe is that it starts pecking the disc more often. And this right here is just a brilliant illustration of their entire philosophy. They came up with the terms reinforcer and punisher. See, a stimulus isn't defined by whether it's good or bad for the animal. It's defined only by its measurable effect on behavior. If a stimulus makes a behavior happen more often, it's a reinforcer. If it makes a behavior happen less often, it's a punisher. That's it. The definition is in the data, not in your head.
And for a good long while, maybe nearly half a century, behaviorism was the undisputed king of American psychology. Its ideas shaped everything from advertising to parenting to education. But, as they say, no rain lasts forever. And by the 1960s, some serious cracks were starting to appear in its foundation. You can really see the whole story arc right here. It kicks off with Watson's radical experiments in the 20s. Then you have Skinner's complete dominance in the 40s and 50s. That was the heyday. But by the 1960s, a new generation of psychologists started asking tough questions that behaviorism just couldn't answer. Like, how do little kids learn language so incredibly fast? What about memory or problem solving? To explain these complex things, they realized they had to break the ultimate behaviorist taboo. They had to look inside the black box. And that was the dawn of what we now call the cognitive revolution.
But hold on, that doesn't mean behaviorism just vanished into thin air. Not at all. While its purest form isn't really the dominant force anymore, its core principles are still incredibly influential. This idea that you can shape complex behaviors through reinforcement, that's the foundation for many types of modern therapy, for special education techniques, and for pretty much all animal training today. And this leaves us with a really challenging question, one that kind of messes with our whole idea of who we are. If every single action you take is simply the end result of a long history of reinforcement and consequences, is you really the one making the choice? Behaviorism forces us to confront this deep philosophical question. Is our sense of free will just an illusion? And that's a question psychology is still wrestling with today.